Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to be looking at Saturn and Neptune coming to opposition. I have taken a look at Neptune specifically quite recently, and only a couple of months ago, we took a close look at the planet Saturn as well. So although I will give a couple of close-ups of each planet during this video, I will be concentrating on their position and what these planets coming to opposition means. Here comes Saturn, and Saturn will reach opposition much earlier than Neptune on just the 8th. Saturn will be at opposition, so directly behind the Earth relative to the Sun, just like the full moon. And there we go. Just about 20 minutes past midnight, and Saturn is directly above the south. So Saturn will be above the south at midnight, give or take, depending on your time zone and how close you are to the center of your time zone, but very much in a similar position to the full moon. So when a planet is at opposition, that means we are seeing it at its most illuminated, because planets like Saturn and Neptune are further from the sun than the Earth. We will always be looking at their illuminated face. The face of the planet facing us will always be the face of the planet facing the sun, because we're closer to the sun. With the angles, it's not exactly perfect. So if we're seeing Saturn when it's not at opposition, if we're seeing Saturn kind of out to the side of the sun, then we may see a little bit more shadow. We may see a shadow of Saturn on its rings. Whereas here, at opposition, Saturn's shadow is directly behind it on its ring, and therefore we can't see that shadow. That will vary at other times of the year, and it's one of the biggest differences when it comes to Saturn between opposition and not being at opposition. Of course, these planets are also closer to us at opposition. So if we take a look over here, the distance from Saturn to the Sun is 9 and a bit astronomical units. The distance from the Earth to the Sun is 1 astronomical unit. And because the Earth is between Saturn and the Sun here, we're seeing Saturn at only 8 and a bit astronomical units away. 1 astronomical unit less than the distance between Saturn and the Sun. So I'm going to get rid of the atmosphere, and I'm going to get rid of the ground. It would only get in the way. If we start moving through time, we will come back to the date where Saturn was also at opposition, but on the far side of the Sun. So there is a major and a minor opposition. Now, here we go. We're starting to see the shadow of Saturn on the ring there. So that's telling us that we're almost forming a triangle, or a right angle triangle with the Sun, the Earth, and Saturn at the corners. So the Sun is sort of, off there at an angle, shining on Saturn, and we're seeing its shadow falling on the ring behind us. We'll keep going through. I hope I'm going the right direction here. Because when Saturn is directly on the far side of the Sun compared to the Earth, of course we will no longer be able to see it, but that shadow will be directly behind the planet again. Now, we have to go through a lot of time here, because although Saturn is itself orbiting based on the shadows, we'll come back a little bit, because Saturn is orbiting the Sun itself, it is moving. But it takes a long time for Saturn to orbit the Sun. It's 20 odd years, 26, 27 Earth years for Saturn to make one complete orbit around the Sun. In fact, that might actually be down here. So it takes 29 years for Saturn to orbit the Sun. Of course, we're moving as well, so we'll see it come back to the same relative position at a slightly different time. But there is Saturn, and we're not seeing any shadow. So if I pull back, the atmosphere is out of the way, but the Sun should be, yeah, there's the light of the Sun very nearby. So close, not exactly, but definitely very close. We can see that Saturn is almost directly on the opposite side of the Sun there. Of course, thanks to the tilt of the Earth and any inclination in Saturn's orbit. So I always say that the planets orbit the ecliptic, and generally speaking, roughly they do, but there is slight inclinations with the planets where they may go a little above or a little below the orbit, below the ecliptic or above the ecliptic over the course of their orbit. We're also seeing, if only we could see Saturn's rings when it was directly behind the Sun. It looks like they were at a very nice angle there. We'll come back up to today, and we'll see that the angle does change thanks to the tilt of Saturn, the tilt of the Earth, coming up to here. This looks like it's there we go. This looks like it's about the minimum. I believe this was pretty close to the time when I made a video just about Saturn. We can see there the rings look much, much thinner thanks to the change in the angle. Saturn's equator, those rings would be practically invisible. So the fact that there is some subtle changes in tilt going on here is great. And it looks like coming back up to the 8th at opposition, the rings look pretty good there as well. They're certainly not as thin as they could be. So that is Saturn at opposition. When to the Sun, of course, it's closer to 10 and a bit AU away from us because it's our distance to the Sun plus the distance to Saturn. But it doesn't really matter because we don't get to see Saturn when it is at a major opposition, forming a line with the Earth with the Sun in the middle. We only get to see Saturn outside of major opposition. The opposition we get to see is the minor opposition. Again, Saturn, the Earth, and the Sun are forming a straight line, but it's Earth that's in the middle at minor opposition. Coming up to Neptune. And definitely with the atmosphere removed, zooming in a little bit, there's a faint little dot there. But Neptune is an incredibly distant planet. So we can see here, we've gone from being 9 and a bit AU to almost 30, 29 and a bit AU. But we can see it's pretty close to opposition here. There's only a difference of 0.1 of an AU, a tenth of an AU, but that difference will come down to being almost exactly a difference of just 1 AU once we get Neptune up to opposition, which will be happening a little bit later in the month. It looks like it's around here. So as with eclipses, as with the Lune at 100%, as with the Moon, not La Lune, not in English at least, just like with the Moon, we may not get to see Neptune or Saturn at the exact moment of peak opposition from here in Ireland, just like the maximum of the full moon. That's something that happens quickly enough and transiently enough that we may actually miss it here in Ireland. So we can see here, if we take a look at the distances, we are almost exactly 1 AU closer to Neptune than it is to the Sun, almost. But we can see there as we move through the days, we get to see 28.896 and 28.898, but we don't get to see 28.897, at least. We haven't just there. But Neptune should be directly behind the South when it's at opposition. So if we get things back visible here, get the ground back visible, so we can see here that Neptune is pretty much directly above the South. We'll move back just a little bit, so it's actually directly above the South. We're still not seeing it at the exact moment of opposition, but we're going to do the exact same thing. We're going to zoom in on Neptune here. We're going to have a look at it at this minor opposition, and then we'll move back around to major opposition, and I will take away the atmosphere and the ground as well, so the view stays comparably the same. We can see Neptune's very, very thin ring there. You may also be able to tell that when we're looking at Saturn, we're seeing the leading edge of its ring lower than its equator. But when we're looking at Neptune here, we're seeing the leading edge of its ring, or the side of its ring that's pointed towards the Earth at least, higher than its equator. So Neptune's ring seems to come out from behind the planet, up and around in front of the planet, whereas Saturn's ring seems to come out from behind the planet and then down in front of the planet. And that's just a difference in the relative tilts between these planets and the Earth. So we'll zoom in here, and we can see that Neptune seems pretty on its side. It seems pretty tilted here. We'll move back through the year, and we'll see it coming around. That thin outer ring is barely becoming visible there. It's not, barely visible there on the other side, but I think it's a little easier to see over here. Neptune's ring, how much we get to see it, depends on how it's reflecting light back to the Earth. So the angle can matter, and changes in the angle, just like the changes with Saturn's ring, they can affect the visibility of the ring around Neptune, even though it's much, much less. So we can see ourselves coming back around here. Around here, we're getting close to forming that right angle, but we're not really seeing, we're seeing a little bit of the shadow there, but Neptune's so far away and its ring is so thin, it's going to be really hard to pick that out. We'll keep moving backwards. There we are, 30 AU, so the distance from Neptune to the Sun, plus the added AU to get all the way back to the Earth, just about, very nearly, these are big numbers we're working with here, so it'll take a while to come back around perfectly. But Neptune is 29.9 AU. Oh, we seem to have passed it there. We're seeing it at 38.8 30.89 AU, 30.89 something, 895, 896 cent. We're not quite, no, we started going back down again. So even working with a tenth, hundredth, a thousandth of an AU, it's hard to get it to match up perfectly just looking at the numbers. So again, from here in Ireland, we may miss the exact point of the major opposition between Neptune, the Earth, and the Sun, but we're not going to see it at the major opposition anyway, only at the minor opposition. So they're looking at everything together. It looks like Neptune's practically directly behind the Sun there. So that's Neptune at its furthest from us, on the opposite side of the Sun. The opposition that we care about is, of course, the one that we get to see when it's on the same side of the Earth. And we can see that there is months of a difference there. And even more so with Neptune compared to Saturn. This is because of Neptune's movement around, or not Neptune's movement, this is thanks to our movement around the Sun, because Neptune's movement around the Sun takes so long that it ends up being pretty subtle. It takes years for us to notice that motion, and down there on the side, I won't bring my mouse over to it because I don't want Neptune to whiz out of view as we zoom back through the year up to, not the current date, but up to the date of the major opposition, or minor opposition. I have a tendency to get those mixed up. So we're seeing it there at just a little, close enough at least, end of September. So we can see there that the year on Neptune is closer to 100 years here on Earth. So it takes a long time for Neptune to get around the Sun. But of course, our motion around the Sun will bring it back to the same relative position a little sooner than that, just like it did with Saturn. So they're the oppositions. The important thing about the opposition is that it's when the planet is at its closest to us, so it appears it's largest in the sky. That's especially useful for brighter planets like Jupiter. They'll be that bit bright and prominent, but they're also with us for the entire night, just like the full moon. So when these planets are at their closest to us, they're also in the sky for the longest possible amount of time, the entire night, which gives us plenty of time to observe them, and we're observing them at their closest. So they are at their easiest to observe when we have the longest to observe them, which is nice. So that's Saturn and Jupiter coming around to opposition this month, the 8th for Saturn, later in the month for Neptune. And Saturn, of course, will be visible to the naked eye. You'll need a telescope or binoculars to take a closer look at Neptune. But I hope you enjoyed this quick video looking at their respective oppositions and the different types. Oh, there was a meteor. That's always nice to see, even in simulation. I hope you enjoyed this video. If you did, make sure to like it. You can also read some of this information on my website, queevinscontent.ie. And if you'd like to encourage me to make more videos, then make sure to subscribe to this YouTube channel. Hopefully, I'll see you back here next time.